Welcome to this comprehensive guide on finding the area of a sector. Today we'll explore one of the most practical applications of circle geometry that you'll encounter in mathematics. A sector is simply a slice of a circle, defined by two radii extending from the center to the edge, connected by an arc. Think of it as a piece of pie or a slice of pizza. Just like cutting a pizza into slices, each sector represents a portion of the complete circle. The size of this portion depends on the central angle between the two radii. The formula for finding the area of a sector is beautifully simple. We take the central angle theta, divide it by 360 degrees to find what fraction of the circle we have, then multiply by the total area of the circle, πr². In this video, we'll master this formula through detailed explanations and practical examples. You'll learn to calculate sector areas with confidence and understand the reasoning behind each step. To understand how to calculate the area of a sector, we first need to identify and understand the key components that make up any sector. A sector is a portion of a circle that looks like a slice of pizza. It's the region enclosed by two radii and the arc that connects them. Now, the first crucial component of any sector is the radius. The radius, represented by the letter r, is the distance from the center of the circle to any point on the circle's edge. Notice that every radius in a circle has exactly the same length. This distance r is constant, no matter which direction we measure from the center to the edge. The second essential component is the central angle, represented by the Greek letter theta. This is the angle formed by the two radii at the center of the circle. The central angle determines the size of our sector. A larger angle creates a bigger sector, while a smaller angle creates a smaller sector. The third component is the arc itself, the curved boundary of the sector. The arc length depends on both the radius and the central angle. Understanding these three components, the radius, central angle, and arc, is absolutely crucial because they are the building blocks for calculating the area of any sector. In the next section, we'll see exactly how these components work together in the area formula. The relationship between the radius and central angle will determine how much of the total circle's area our sector contains. Now we'll explore the formula for calculating the area of a sector when the central angle is measured in degrees. This formula is fundamental to understanding how sectors relate to the complete circle. To understand this formula, we need to visualize what a sector looks like. Here's a circle with a sector highlighted in yellow. The sector is the region between two radius lines and the arc that connects them. The formula has three key components. A represents the area of the sector we want to find. Theta is the central angle measured in degrees, and r is the radius of the circle. The key insight is understanding the fraction theta over 360 degrees. This fraction tells us what portion of the complete circle our sector represents. Since a full circle is 360 degrees, this fraction gives us the sector's proportion. The second part of our formula is πr², which is the area of the complete circle. We multiply our fraction by this total area to get the sector's area. Putting it all together, the sector area equals the fraction of the circle that the sector represents, multiplied by the total area of the circle. This gives us our formula. A equals theta over 360 degrees times πr². This formula works because it calculates exactly what fraction of the circle's total area the sector occupies. Whether your sector is small or large, this proportional relationship always holds true. Now we'll explore the area of a sector formula when the central angle is measured in radians instead of degrees. This alternative formula is equally important and often more elegant in advanced mathematics. Before we dive into the radian formula, we need to understand what a radian is. A radian is a unit of angular measurement. 1 radian is the angle formed when the arc length equals the radius of the circle. When the central angle is measured in radians, we use this formula. A equals 1/2 times r² times theta. Here, A is the area of the sector, r is the radius, and theta is the central angle measured in radians. Understanding why this formula works helps us use it correctly. The derivation starts with the fact that a full circle has area πr² and measures 2 pi radians. A sector represents a fraction of the full circle. The fraction is theta over 2 pi, where theta is our angle in radians. Multiplying this fraction by the full circle area gives us the sector area. When we simplify this expression, the pi terms cancel out, leaving us with 1/2 times r² times theta. This is our elegant radian formula. It's crucial to use the correct formula based on whether your angle is measured in degrees or radians. When the angle is in degrees, use the formula with 360 degrees in the denominator. When the angle is in radians, use the simpler formula with 1/2. Remember these key points. Always check the units of your angle first, use the appropriate formula for those units, and remember that both formulas will give you the same correct result when used properly. The radian formula is particularly elegant and is preferred in advanced mathematics because it eliminates the need for the conversion factor that appears in the degree formula. Now we'll work through our first example to see how the sector area formula works in practice. This will help you understand each step of the calculation process. Here's our problem. We have a circle with a radius of 5 units, and we want to find the area of a sector that has a central angle of 72 degrees. Let me show you what this looks like visually. Here's our circle with radius 5 units, and this highlighted sector has a central angle of 72 degrees. Now let's solve this step by step using our sector area formula. Step 1. We start with our sector area formula. A equals theta over 360 degrees times pi r². Step 2. Let's identify our values. Theta equals 72 degrees and r equals 5 units. Now let's substitute these values into our formula. Step 3. We substitute our values. A equals 72 degrees over 360 degrees times pi times 5². Step 4. Let's simplify the fraction. 72 over 360 equals 72 divided by 360, which simplifies to 1 over 5, or 0.2. Now we can continue with our calculation. Step 5. We calculate r². 5² equals 25. Step 6. Now we put it all together. A equals 0.2 times pi times 25, which equals 5 pi² units. Let's also calculate the decimal approximation for a complete answer. Here's our final answer. The exact area is 5 pi² units. As a decimal approximation, this is approximately 15.71 square units. We found this by using the sector area formula with theta equals 72 degrees and radius equals 5 units. This completes our first example. Notice how we carefully substituted each value and simplified step by step to reach our answer. Now we'll work through our second example, this time using radians instead of degrees. This will show you how the radian formula makes calculations more direct and elegant. Here's our problem. Find the area of a sector with radius 4 units and central angle pi over 3 radians. Let me draw this sector for you. We have a circle with radius 4 units, and we're looking at the sector formed by a central angle of pi over 3 radians. The radius is 4 units, and our central angle is pi over 3 radians. Notice that pi over 3 radians equals 60 degrees, but working in radians will make our calculation much simpler. Let me clearly identify our given values. We have radius equals 4 units and theta equals pi over 3 radians. For radians, we use the formula area equals 1/2 times r² times theta. This formula is actually simpler than the degree formula because radians are the natural unit for measuring angles. Now let's substitute our values into the formula step by step. Step 1, we start with our formula, A equals 1/2 times r² times theta. Step 2, now we substitute our values. R equals 4, so r² becomes 4², and theta equals pi over 3. Step 3, we calculate 4², which equals 16. Step 4, now we multiply these values together, 1/2 times 16 times pi over 3. Step 5, when we multiply 1/2 times 16 times pi over 3, we get 16 pi over 6. Step 6, we can reduce this fraction by dividing both numerator and denominator by 2. 16 divided by 2 is 8, and 6 divided by 2 is 3. So our exact answer is 8 pi over 3 square units. If we want the approximate decimal value, 8 pi over 3 equals approximately 8.38 square units. Notice how much simpler this calculation was with radians. Unlike the degree formula, where we had to divide by 360, the radian formula works directly. This is why mathematicians prefer radians. They make circular calculations more natural and elegant. So our sector, with radius 4 units and central angle pi over 3 radians, has an area of exactly 8 pi over 3 square units, or approximately 8.38 square units. Sometimes in mathematics, we encounter problems where we know the area of a sector and one other piece of information, but we need to find a missing variable. This requires us to rearrange our sector area formulas to solve for the unknown. When we need to find the radius, we rearrange the formula to isolate r. For the degree formula, we multiply both sides by 360 degrees, divide by pi and theta, then take the square root. Similarly, when we need to find the central angle in degrees, we multiply both sides by 360 degrees, then divide by πr². For the radian formula, finding the radius is simpler. We multiply both sides by 2, divide by theta, then take the square root. Now, let's apply these rearranged formulas to solve some problems. Our first example will find the radius when we know the area and central angle in degrees. First, let's identify what we know. The area A equals 50 square units, and the central angle theta equals 72 degrees. We need to find the radius r. We'll use our rearranged formula for finding radius with degrees. Recall that r equals the square root of a times 360 degrees divided by theta times pi. Now let's substitute our known values. A equals 50 and theta equals 72 degrees. Let's calculate the numerator first. 50 times 360 equals 18,000. Next, we calculate the denominator. 72 times pi equals approximately 226.19. Dividing 18,000 by 226.19 gives us approximately 79.58. Taking the square root of this value gives us our final answer. For our second example, we'll find the central angle when we know the area and radius. Let's identify our known values. The area A equals 75 square centimeters, the radius r equals 10 centimeters, and we need to find the central angle theta. We'll use our rearranged formula for finding the central angle. Theta equals a times 360 degrees divided by pi times r². Now we substitute our values. A equals 75 and r equals 10. Let's calculate step by step. First, 75 times 360 equals 27,000. Next, pi times 100 equals approximately 314.16. Finally, dividing 27,000 by 314.16 gives us approximately 85.94 degrees. Our final example will demonstrate finding the radius when the central angle is given in radians. Our known values are area A equals 40 square meters, central angle theta equals 2.5 radians, and we need to find radius r. For radians, we use the simpler rearranged formula. The radius equals the square root of 2a divided by theta. Substituting our values, a equals 40 and theta equals 2.5 radians. First, we calculate the numerator. 2 times 40 equals 80. Next, we divide 80 by 2.5, which equals 32. Taking the square root gives us our final answer. These examples demonstrate how algebraic manipulation allows us to solve for any unknown variable in sector problems. The key is identifying what you know, choosing the correct formula, and carefully performing each calculation step. Now that we've mastered the formulas for calculating sector area, it's time to explore how these mathematical concepts apply to real-world situations. Sector area calculations are used in many practical fields, from food service to engineering design. Our first application involves something we all love: pizza. When a circular pizza is cut into slices, each slice is actually a sector of the circle. Understanding sector area helps restaurants determine portion sizes and pricing. Consider a 14-inch diameter pizza cut into 8 equal slices. Each slice has a central angle of 45 degrees. What is the area of one slice? First, we find the radius. Since the diameter is 14 inches, the radius is 7 inches. Each slice has a central angle of 360 degrees divided by 8 slices, which equals 45 degrees. So each pizza slice has an area of approximately 19.2 square inches. This calculation helps pizzerias ensure consistent portion sizes and fair pricing. Our second application involves irrigation systems. Sprinklers often cover a sector-shaped area, rather than a full circle, especially when placed near boundaries or obstacles. A sprinkler has a range of 15 feet and covers a 120-degree sector. What area of land does it irrigate? Using our sector area formula, with radius equals 15 feet and theta equals 120 degrees, we calculate the area step by step. The sprinkler irrigates approximately 235.6 square feet. This calculation is essential for landscape designers to ensure adequate water coverage and avoid waste. Architects frequently use sector calculations when designing curved elements like arches, domes, and decorative features. These calculations ensure proper material usage and structural integrity. An architect designs a semicircular arch with an outer radius of 8 feet and inner radius of 6 feet. What is the area of material needed for the arch? We calculate the area by finding the difference between the outer sector and inner sector. Both have 180-degree angles, so we use the sector formula twice. The arch requires approximately 44 square feet of material. This precise calculation helps architects order the correct amount of materials and estimate costs accurately. These real-world applications demonstrate the versatility and importance of sector area calculations. From everyday situations like pizza portions to professional applications in architecture and landscaping, these mathematical concepts have practical value. Throughout this video, we've learned two essential formulas for calculating sector area. The degree formula uses theta over 360 degrees times πr², while the radian formula uses 1/2 times r² theta. Remember that these formulas work because a sector is simply a fraction of a complete circle. The key is identifying the radius and central angle, then applying the appropriate formula based on whether your angle is measured in degrees or radians. Mastering sector area calculations opens doors to solving many practical problems in engineering, design, agriculture, and countless other fields. These mathematical tools empower you to analyze and solve real-world challenges with confidence. Thank you for joining me in exploring the area of sectors. If this video helped you understand these important concepts, please give it a thumbs up and subscribe for more mathematics tutorials. Leave a comment below if you have questions or suggestions for future topics. Keep practicing, and remember that mathematics is all around us in the real world.